Let me look at so just to first show how things are structured. Oops, I guess this might be not working well. So here is the main file with the website and the code that we just saw. And this is the module scrape the website. Here in the same project, I have also the plotting in Bokeh. And I have a version where I plot in Matplotlib. I'll share this with you guys. It's less elegant. I don't think Matplotlib is good at, for example, scaling for real application, doesn't have menus and buttons, but it can do very good, interesting things in terms of the basic plotting of the data. So for those interested, I'll just keep at least the same example so one can do side-by-side comparison. So let's first look at what do we want to accomplish. So this is the website. Those are the four nations, Italy, USA, and Brazil. I'll show why I have two ways of naming those. In some cases, this is more important than other. But basically, there are codes for the nations. For example, the US, the code is actually US, and there is the actual name, and those are different. And then here, those are the number of people per nation. So the US, for example, has 330 million. Out of those three is the larger country. So let me go to the website first. Oops. So this is this kind of world meter website. Has all kind of interest, curiosity about number of people born and died per year and so on. And by the way, I don't claim that this website is in any way particularly accurate. It was just easy, and for the purpose of the class, that's kind of really what we need to have. So here they have this pre-made plots. Again, ideally you want to have better control over. So this is the total daily new cases per in the world. And so here's the raw data here to kind of plot the smooth the data a little bit. I embedded that in the application, and here's the daily deaths. This is too much. So, but you see the data is very noisy, and then you want to smooth it away. What's interesting here, they have this nice table where it's a list of nations. The data actually can be sorted in different ways. So here is the number of cases, number of deaths. So basically you can sort, I think the default, they're defaulted to sorting by number of cases. You can sort by total number of deaths. So those numbers are kind of interesting, more, but not very useful just because they don't normalize by the size of a country, right? A country is twice as big. Obviously, you would expect to have twice as many cases. So the raw numbers are not very interesting. Surprisingly, they put the normalized numbers down here. So for example, total number of cases per million. Now suddenly it's a completely different ranking. So US that was at the top is down here at 18th place. UK is 19. Here there are several countries either from Eastern Europe or other places. Interesting, for example, Netherlands is higher than the US. Let me see. And then the number that I consider kind of the more hardcore number, the one that is harder to dispute, is kind of number of deaths. And here actually the deaths per million population, unfortunately, Peru is at the top of that. And so let's see, we're looking at USA is down to position 20. Let me see. Where is, I'll do it. Brazil is ranking 11, and Italy 26. Again, it's not very important, the ranking, because they could be ranked for very differently. But for example, we have 2,200, 2,000, almost 400, the USA, and Brazil, 2,800 plus. Anyway, so what's interesting here, apart from, so you can play with this and so on. And then but you cannot really compare visually. You would have to here go, let's say, I go to Italy, then I goes to a new web page. This is the actual code that I was putting in my array. So now you go to the individual page, and then you can start seeing the plots of daily cases or deaths and so on. So it's very hard. You have to kind of memorize those plots and go back and then go to another country and look at a different plot, and then kind of in your mind do a comparison. And that's why I provided an example. So here I go to the US. For the US, actually, there is numbers for the individual states. So one can even do the same thing within the US, but those are the global statistic about for the US in terms of plotting and so on. As you can see, it's kind of looking at this and the other plot, it's kind of, and they have different scales and no normalizations, very hard to compare. So we can do better on our own doing the plots, but the challenge is to get the data. So here, if you do right click, I'm using Chrome, but every browser has similar capability. I can go to the menu, view page source. And so this is the actual raw HTML code that, let me move this. So that is actually doing the plotting of the data. So now it's not important to understand all this. You can just do now find, for example, and let's find USA somewhere. There must be. So I start searching. Maybe USA is not a good search because it's part of keywords like focusable and so on. Let's look for Italy. That's definitely not going to be it. Right. Okay. So now Italy. So here you see country Italy. This is the code that I was talking about. Here's where we'll have to look when I want to know the actual population. For now, I copied this number and I put it, cut and paste in there. That makes sense if you're just doing like 3 entries like this. Later on, I'll show how to scrape also for this data. But then, let's see. No, okay. So this is the main page. I made a mistake. That's good. So this is what I will parse later. So to do the scraping on the number, I have to go to the sub page of Italy. That was actually, so this is kind of the unification. We're going to go for each of those pages and get the actual plot. So now we look at the source code of this page. Again, let's look at where the plot for the data for the plots is going to be here. So here, for example, we go look for deaths. So here is the sequence of dates. So it's already a very important important piece of information. This is what we will have to plot. If you go back, this is what we want to plot here in x-axis. We want to know when a certain number of deaths happen. By the way, this is kind of a very long array with all the and then we're going to look for, so let's look at where the plot is. Okay, so here the daily deaths, we were trying to kind of get this information, this 700, 430 and so on. And so here we do the so here we have daily deaths, and here you go to daily deaths. It's a series And this is the actual raw numbers. Also notice that there is a 3-day moving average and 7-day moving average. Null, it's something that we have to interpret as an additional 0. They really probably don't have data at that stage, but it's safe to assume they always start from 0 and go up. So typically you have a few nulls. And so this is actually a way to understand how the data is structured. So what do you have to do to fix it? So this is the data. Here you see that there is the 3-day average and the 7-day moving average. One thing that I didn't do, I could have done, is to get directly the 7-day moving average. Instead, what I'm doing, and that's kind of a way to have more control, I took the raw data. So if you want, we can see the jaggedy data. And then I did the smoothing directly using SciPy. Again, it's such a 2-line of code, so it makes everything slower, but from an education perspective, it's kind of an interesting thing to do on your own. You can not always rely on the fact that the data is already smooth. So here the idea is that, okay, I have to look, open the Italy page, so get country Italy, then search all the way somewhere here, find a way to get skip all the line before this, then get to the open square bracket, get all these numbers, replace the null with a 0, and that's basically the set of values that we need. And later on we'll do a plot, but at this point we'll just stop at collecting the numbers.